Oh, it started. Okay, here's a new recording on another problem. C7H18N2, 0 unsaturations. Looking at the IR. Anything pop out from the big four? And we know we have nitrogens. So the little rabbitier guys here, NH stretches. So we have NH stretches, NH2 probably. Around, that's hard to read, around 30, I'll just say 3,300 reciprocal centimeters. So, and then that's about it. We don't have to worry about any of that. So NH, and we have nitrogens. We just don't know, since there's two nitrogens, how that's set up exactly yet. In the proton NMR, we have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 hydrogens. That's how many we're supposed to have, right? Total. And then 1, 2, 3, 4, 5 carbon signals. And we have 7 carbons. So we have 2 carbons doubled up. And it kind of looks like that one and that one. So we'll just have to keep that in mind. I'm going to tentatively say 2 carbons there. Now, interpretation. 6 hydrogen triplet. 6 hydrogen triplet pretty much has to be a CH3 and another CH3. But they can't be connected to the same carbon like in the last problem, because there would be no way to get them to be a triplet then. If these two are connected to the same carbon again, and that carbon's connected to something else, another carbon, then there's only one hydrogen there to split these, and there's no way that these can be a triplet. If you put another hydrogen here, they would be a triplet, but then you've just made propane, separate molecule, and you're done. So it's not that. So what we see then necessarily must be methyl triplets duplicated. So one signal for the methyl, split 2 additional times, methyl triplet, methyl triplet. Then there has to be a pair of CH2 signals that are identical. Well, no, we don't know they're identical. They're probably identical. Elsewhere in the spectrum. So looking elsewhere in the spectrum, there's a 2 hydrogen singlet. Ooh, this sort of jogs my memory from the last problem. I said oxygen and nitrogens with hydrogens are usually not split. Those hydrogens are not split usually. So a 2 hydrogen broad singlet is probably an NH2 in this problem, almost has to be. It agrees with the IR, it agrees with the formula, and the NMR. So that means the other nitrogen doesn't have hydrogens, might not have hydrogens on it. Okay, so then there's a 2 hydrogen highly split signal. 1, 2, 3, 4, 5. So it's a pentet. There's a 2 hydrogen triplet. Well, these can't be 2 hydrogen triplets. And then there's 6 hydrogens, so it looks like there's overlap here. So real data, hard to say what's what there yet. These can't be triplets. At the minimum, they have to be quartets, right? Because you get a signal for the 2 hydrogens here, split 3 more times, that's a quartet. There are no quartets, at least unless it's buried here. Okay, so, but maybe that's the case. So where's our formula anyway? C7H18N2, C7H18N2. We can subtract NH2, C7H16N. We can subtract C4H6, 7, 8, 9, 10. C3H6N. So we're getting down there. All right, so what else can we figure out here? A 2-hydrogen triplet that's more de-shielded, but there's only one of them. So, and then a 2-hydrogen pentet. Well, this is, on its way to being a pentet, but you would then end up having to have just a CH here to make this a pentet, right? It's a quartet with one more split. I don't know if it would even look quite like a pentet because of that. But there are no CHs, really, unless it's underneath there again, but that doesn't seem too likely. Because these two methyls are completely and exactly equivalent, it suggests that these two carbons are in a very similar chemical environment as well. So, so they're not triplets, and so they could be quartets. Could it be that there's a quartet under there? Quartet usually looks like this. It does kind of seem like that. It's like 3 of the 4 are there. And then if that's true, what's overlapped with it almost kind of looks like a triplet there. So let's go back. So a pentet we've seen before too. I know it seems like I'm kind of doing random stuff, but okay, so I'm trying to derive the structure from the data. A 2-hydrogen pentet there at 1.6 ppm. We've seen that before. We've gotten clean pentets from an arrangement like this. So you get one signal here split 1, 2, 3, 4 more times into a pentet. So it looks like we've got that. And so that's a CH2 we can subtract from this formula. CH2, C2H4N left. It's starting to look like all CH2s for the rest of the way. Looking at the shielding, de-shielding, these signals are both pretty de-shielded. Here's where you could consult the tables. Notice I haven't consulted tables throughout this whole session, right? Question, yeah?
So at the top we have 1.6 ppm.
Yeah.
Are those two hydrogens chemically equivalent?
Yes.
So what makes them different from, why are you splitting 5 ways instead of 3 ways? Would the hydrogens on the other carbons on the end also be the same group, equivalent?
Yeah, so, okay, so the question is why, well, first it's like, determine that these are equivalent, and they are because they appear in the same signal as integrating for 2 hydrogens. So that proves the equivalence. Once you know that they're equivalent, then you know that it begins with a 2 hydrogen signal. For that to be split into a pentet requires that there's 4 other hydrogens around on neighboring carbons, resulting in 4 additional